This conference will now be recorded.
So today's topic is about Docker containers and their namespaces. Okay. So now everybody had some idea like what is a Docker, what is a container, how to deploy an applications on the container level, like how to run your applications and all. You know all these things, right? So now it is time for us to learn something like beyond Docker, like what is happening beyond your Docker. Okay. So what exactly it is trying to do in order to ensure your applications are running on a same kernel. Okay, so let me draw a simple diagram between the basic difference of how a kernel is used on virtual machine and a containers. Okay, so if you try to compare this, let's say this is your hardware, right? So this is your hardware. Okay, and then on top of this you will be installing some operating system, and then a kernel will be sitting on top of it. Operating system is nothing but, let's say it is a kernel. Okay, so just say, let's say it's kernel, and now on top of this you will be creating a virtual machine. Okay, so you will be deploying some virtual machine, so that virtual machine will be sitting on top of this, and it has its own kernel, right? So this virtual machine will be having its own kernel, and on top of that your applications will be running. So let me define this, and then the application will be running on this. So does any everybody knows what is a kernel right now, right? So a kernel is a piece of code which will interact between you and your hardware, right? So let's say hardware in the sense it can be anything: a RAM or a virtual RAM, CPU or a virtual CPU, disk or a virtual hard disk. So whatever the medium it is, a kernel is important for us to transfer your human readable language into a machine level language, like ones and zeros. Okay, that is the intention of using kernel in operating system. Okay, now when you try to run some application, okay, it will use some libraries and it will use some system calls. System call in the sense every command you run or any application that tries to interact to an kernel, it will use a system calls. So which means that in between them, your application and your kernel, it will use a system calls. Okay, I'll show you practically what is the system calls, how it looks. So it is called a system calls. Okay, so system calls in the sense, let's say I run some df-h command. So when you're running some df-h command, it will pull lot of libraries and binaries, and it will execute the command. It will pass information to the kernel using system calls, and the system, with the help of this system calls, it will interact to the kernel. Kernel will understand what it is exactly, and it will convert into a binary language, and that will be given to your hardware. Okay, in order to get the information. So that is the intention of using a system calls, right? Now when you're running a virtual machine, your virtual machine kernel and your operating like VMs which are created on top of this kernel are different, right? Every virtual machine has its own kernel. So this application cannot contact to this kernel, or this kernel cannot take the calls of this particular application. Why? Because this is completely isolated, and it has its own kernel to execute something on a virtual CPU. See here, it has virtual CPU, virtual memory, and virtual disk, right? Here this kernel will be interacting with the physical disk, physical RAM, and physical CPU. That is the basic difference. That's it. Apart from that, kernel does the same thing. It will use a system calls. Your application or your commands will use a system calls. It will interact it with the help of that. It will contact to your kernel, and it will execute the necessary actions. Okay. Now how I can check the system calls? Okay, system calls can be anything, applications can be anything. Applications in the sense your curl command or your Firefox, or if you're opening some browser, you're executing something related to application. Okay, so anything can be a system call. Okay, so that system call will be used. Everything has its own system call. There are so many system calls actually. Okay, if you search in Google, okay, if you search for that, okay, system calls Linux, system calls Linux. Okay, so if you see, if you'll get whole bunch of system calls actually. Let me open the official like man page. related to system calls. If you scroll down, you can see there are system calls. Okay, you can see there are a bunch of system calls actually. For every action, it will use certain thing. Let's say I want to get a process ID related information. For that, it will use get PID. Okay, so it will use this particular system call in order to get the information related to your process. You can see get process identification. Okay, so we are executing PS command, we are executing some top command or something, right? Top command will do so many things. Among them, it will collect the information related to process ID as well, right? So it is using this kind of system call in order to take the information. The df command will call this particular system call, and this system call will be used in order to get the information. How the system call is developed? It is developed on C language. Okay, you already know that your kernel is entirely developed on C and C++. Okay, so the base like languages C and C++. You can see here. Okay, so using that, it will try to get the information. Okay, that is the first thing which you have to understand about your base operating system. Okay, whether you are running your application on a bare metal or a virtual machine, it will use a system calls, it will talk to the kernel with the help of that, and it will get the information. So is this point clear, so that we can go to the next level? Okay, done. Right, now coming to the virtual like containers, what happens exactly? So in containers, you will have a hardware. Okay, anything, right? Hardware is a hardware, that's it. Whether it is a virtual machine hardware or a physical machine hardware, it is up to us where you try to deploy your containerization to. Okay, now we have a hardware. On top of that, okay, so let's say you have installed some operating system. So when you install some operating system, automatically it has some kernel, right? So there is a kernel. Okay, now you're trying to create a container. So let's say you deployed some containerization tool like containerd or docker, and then you created some container, right? Now you created some container. Okay, it is running with some application. Okay, now this particular application, if you try to see this documentation as well, okay, every application will use certain system calls in order to talk to the kernel in order to get the information from the hardware, whether it is CPU or memory or a hard disk. Running process issues request to kernel to interact with a piece of hardware. That is the intention of using system calls. Okay, now what happened exactly? Now, if you're trying to see this, every container is sharing the same kernel, right? So if you try to create another container, it doesn't have its own kernel, right? As I already told you, it will have only libraries and binaries of that particular operating system. Okay, let's say you are running one application. Okay, it is using an image called, let's say it is CentOS image. Okay, and this is Ubuntu image. Now, this application, the container will have only a libraries and binaries related to run your application on this container. And it will have all the CentOS related libraries and binaries to run the application on this container. Now, now the problem is everybody, like this container is talking to this kernel, and this container is also talking to the same kernel. Okay, it will use some system calls in order to talk to it. How your container will have a system calls? It is having a libraries and binaries, right? Automatically it will have a system calls. Okay, and it will use that particular system calls in order to talk to that particular system. Okay, now if you see this diagram, let me open that PDF actually, where I opened it. Sorry, I just missed it. Okay, let me open now. Give me 2 minutes, I'll just open that. Lucid, I've created some diagrams, so I just want to show you. So if I click on this, I have my agent over here. Let's see. So this will explain your continuous. Okay. Now you have hardware. You are having OS kernel. and then you are using some system calls like, let's say, get pid, a reboot. For rebooting, you execute a reboot command, right? Actually, that reboot command will call, it will use a system call called reboot system call, and then it will pass information to the kernel. Okay, the system calls and the OS kernel is called as kernel namespace. Okay, and the libraries and the application which is running is called as user namespace. Okay, user space it is. Okay, so now if you look at our diagram, okay, you look at our diagram, yeah, so every application and the system calls which it is using is, it is called as user space. Okay, and the kernel and which it is running, it is called as kernel space actually. Okay, so now these applications, when they are talking to the kernel, though they are isolated, okay, so now this container cannot see the information related to this container, it cannot see this information. How? Because they are isolated with the namespace. Okay, so namespace in the sense, when you try to create an install an operating system, by default it will have some namespace. I will show you practically how to create a namespace without having containerization tool. Okay, before that, let us try to understand what is a namespace. So namespace in the sense, you are trying to isolate the information, whether it is a process or whether it is a memory or whether it is a CPU or whatever it is, you are trying to isolate from other applications. Okay, there will be so many process running in your operating system. Okay, if you want to separate these some amount of processes, you want to isolate from your base operating system, you create a separate namespace and you run some particular process in that particular namespace. Okay, so because of that, what will happen, the information which is running or the process which is running in that namespace cannot be seen by everyone, like other namespaces actually. So which is nothing but you're isolating with each other. Okay, so that is the advantage which was taken care by your Docker. So Docker will use that particular feature which is already present in Linux operating system. Okay, this is a feature which is already present in Linux operating system, it is not something Docker has built it. Okay, so Docker is utilizing that particular namespace feature in Linux operating system in order to isolate one container to another container. So that's the reason you will not able to see the information which is present in one container, other containers cannot see it. Okay, let me show you the proof that. Okay, so how these namespaces are isolated with each other. So in order to show that, first of all, let me log into my Docker host machine. So this is my Docker host machine which is it is running actually. Okay, forget about that, the container which is running. Okay, so now let me to create one container and another container, and let me show you how they are two are isolated. Okay, so now yeah, before that, I want to show you the namespaces which are already present in your Docker host machine. Okay, so if I execute this, you can see there are so many namespaces which are present in this particular operating system already. Okay, among this, let us, we are trying to create other namespaces as well for Docker. So every container will create its own namespace. Okay, I well documented here. I will show you the details of this document. Okay, once it is done. Okay, so I will share you those documents. So now PIT. Okay, now totally you have two namespaces which are present in your operating system. One is used by your base operating system. This is a root, this is a root namespace. Under that, it created another namespace called for port trainer. Means you are trying to run a port trainer container, right? This container is using a different namespace. You can see the ID, which is a different. Okay, you can see this is the command which is running in the container. You can see this. Okay, and you see, I will tell you what is this process ID, why it is showing you here 1, and why here it is showing you 1046. I will tell you, explain you once again. But this is a root namespace. Okay, and this is your parent namespace, child namespace, it is called as child namespace, which means that in that namespace it is created a separate one. Okay, so both are isolated with each other. Now let me create two containers. Okay, so Docker container run, okay, hyphen t detach mode, and then let me name the container as c1. Okay, and the image name is, let's say I will use simple ubuntu, and I will run sh -c, I want to run some sleep command. Okay, let's say sleep for 1 day. Okay, so this is a command which I'm running. Now this container is created. Okay, if you log into the container, or let me show you the namespace for this container. So ls ns. Okay, so no need to install any package to run this command. It is an inbuilt feature of Linux operating system. No need to install any package. Okay, so -t pid. Now you can see there is a new namespace which is created. Okay, and then you can see the id for this particular namespace, and you can see the command what you have specified here. That command is running that particular process, not the command. It is created as a process id, right? So that particular process is running here inside this namespace, and the process id inside that particular namespace is 20095. So let me prove that. Okay, I think it will show you here, but on the host operating system you can see that. Okay, so grep sleep. Okay, enter. You can see this on the parent namespace. You can see this. Okay, 20095. Okay, so that is how it is, but inside the container it will be a process id as 1. Okay, so don't get confused with that. Okay, so now if you log into inside the container, exec-ti c1, if I execute ps aux command, you can see this inside it is running as a process id 1. See, every container is created, it will have its own namespace, and what are the process you run? The first process ID, the main process ID will be created with 1. Okay, that's a mandatory. Like that's how it behaves. Okay, so don't get confused with the process ID which is running on inside the Docker host machine and inside the container. Okay, so both are different. Okay, now let me try to create another container, and let me show you the process ID for it which is created on the Docker host machine. Okay, and the parent namespace, and let me show you the child namespace of that particular container. Okay, so now if I try to create here, I will give 999D, means 999 days for this C2 container. Okay, now this is also created. If you try to see this, you can see another namespace had been created. So for each and every operation which you do, whenever you try to create a container, automatically Docker will try to create a separate namespace for process. For memory, it has a separate namespace. For process, it has a separate namespace. For mounting, it has a different namespace. So every namespace which is created for that particular container will be created with some specific ID. Okay, so that's how it will get identified. Okay, now these two containers, if you try to see, where is that process? Uh, Show you that ps command. Okay, so Docker exec -ti c1 ps aux, sorry, aux. Okay, you can see this process id which is running here, and if you see here, both are different, both are isolated. Okay, you cannot see the information which is present in the c1 from c2, and you cannot see the information of c2 container from c1. Both are, you cannot see it, right? You can see that command when I executed, it is printing only the information, the process related information only of that particular container. And if I log into my c2 and if I execute a command, it is showing the information only related to that particular container. Okay, but if I log into my Docker host machine, and if I execute ps aux command, and if I try to grep sleep, okay, it will show you the whole information. It will show you all the containers related information. Whatever the namespaces you have, this Docker host machine can list all the namespaces. Okay, but the namespaces which are
So,
created under
Sudhir,
this can see only that particular information. Yeah, go ahead.
You meant to say that the individual containers, whatever the namespaces it is showing, so
Mhm.
Docker host is showing both the containers information. That is what you are saying, right?
Exactly, exactly.
Okay.
See, Docker host is nothing but your virtual machine, right? Whether you install Docker on virtual machine or a Docker bare metal server, that particular server will show information of all the namespaces. Okay, in information, now this command which I executed, it executed in that particular namespace of this container, and this command executed on that particular container namespace. and the command which I executed here, it ran on root namespace. Okay, on your Docker host root namespace, this command has run. It will show you all the information. How many namespaces you created, on all the namespaces, whatever you are searching for that particular string, it will show you the entire information. Got it? What I'm saying exactly? Or still confused? Please let me know, because this is important actually. Okay. Now, simple. Again, I will repeat that. On the Docker host machine, okay, or on Linux machine, if you execute ps-aux command, it will show all the information, whether how many namespace you create, on that namespace, whatever the process you run, Docker host can see it, or the physical machine can see it. Okay. Now, if I log into a specific namespace and if I try to run some command, it will show information only related to that particular namespace, which means that it is isolated. Okay, so that is the intention I have shown this. Okay, now I want an exception saying that I want to create two containers, but both the containers should share same namespace. Okay, what I mean to say is nothing but, instead of creating two namespaces for two containers, I want to create a single namespace, and that namespace should be used by both the containers. Okay, is that possible or not in Docker? Yes, it is possible. Let me show you practically how it looks. Okay, now this is clear, right? Let me do a cleanup. Okay, so Docker stop C1, C1 and C2 actually. I would have given that. Yeah. This is pretty interesting actually. If you start, watch the video for multiple times. If you are not able to understand right away, see, it will take some time obviously. So let us try to understand, practically try to understand and see the results. Register in your mind, watch the video once again. After this is done, you will understand the whole concept. Okay, so let me remove the containers, and then let me sorry, C1. Okay, done. So the containers which I have created are cleaned up. Sorry, okay, ps hyphen a, only port runner is running, just keep it as it is. Now let me try to create a container. First I will create a C1 container. Okay, so Docker, now if I execute first of all lsns hyphen t pid, I see now only two namespaces. One is parent namespace and one is a namespace which is created by Docker for running a portrainer process. Okay, clear. Now Docker create container run hyphen detach mode hyphen name c1, yeah, c1, and let's say I am trying to use Ubuntu same commands. Okay, sh hyphen c, and then I'm running a command called sleep. This is really important for CKS exam. Okay, to understand the concept. Yeah. Now I executed this command. Okay. Now, now you will see a new process created in that particular new namespace created. In that namespace, it is running this command. Okay. If you want the proof how we executed the PS command, right? You can execute the same thing and see. So in that namespace, in this namespace, now these are the processes which are running. Why it is showing you only one output here? Because it will show you only the parent process id of that particular namespace. Okay, so in this namespace the parent process id is this. You can see process id 1. It will show you only that information. It will not show you process id related information 7 and 8. Okay, so that is how you have to understand the concept. Now let me create another container. That another container will be created in the same namespace of c1. I'm not creating any additional namespace. How to do that? So Docker container. Till now we haven't seen this actually. In any, none of the sessions, like none of the batches, I have not told this actually, because I just want to do some R&D and all, so that's the reason. Okay. Now I'm taking this opportunity. So Docker run hyphen d detach mode and then hyphen fn name. This is C2. Okay, and then I use hyphen fn pid equal to container colon C1. Just a second, guys. So let me go to the node. Yeah, now you can see this is really important. Hyphen fn PID equal to container C1, which means that you are saying that I want to share the process ID of a container called C1. That is what you are trying to say. So I don't want to create. So you are telling to the Docker that please don't create a separate namespace for this container. Use the existing namespace. I want to share the same namespace what C1 is doing actually. Okay. So whatever the command you run in the C2 as well, it will show you in C1. What is running in C1, C2 also will show the same all the information. Okay. See that what will happen exactly. So now, yeah, Ubuntu Ubuntu and you want to run some command called sleep and then 990b. Okay, so this is how it is. Now execute. Now if you see the information in C1, it is showing you both the informations. Why it is showing me this information? You can see I have not executed anything this, right? You can see the information, the process related information which is running in C2, I am able to see from C1. If I execute from C2, you can see the information related to C1 as well as C2, both. So both are showing the same information. Okay, how is this possible? Because both are sharing the same namespace. So that is how it is. So if you want like that, you have to do this. Okay, so this is how it is. Now, if you look at your namespace list, hyphen T, PID, now we can see, is there any other namespace running? No. Why? Because my both the containers are using the same namespace, which is created for C1. Okay, so this is how it is. Okay, always if you want to see some parent process ID and the child process IDs, I recommend to execute ps tree command. Okay, let's say I want to see the process related information of let's say um, just let me execute ps aux pipe grep. Okay, let's execute sleep. Okay, now ps tree. Okay, I want to execute a process related information of 20564. Sorry, let me check this first. Okay, now you can see the system D is a parent process ID which is running. Okay, under this you can see Docker is running this and Docker is running this and this and this. Okay, so under this particular process ID it has created so many things. Okay, you can see the information like how it is getting created. This is your parent process ID. Under that it has created this. Under the Docker shim you can see it is created a sleep command which we have executed right now, and there is a port trainer which is running with one. So two into in the sense there are two containers which are using the same process ID. Okay, so that is what you have to understand. Okay, so this is how the information which you check in the Docker with the process ID is how it is created. So this is called as process ID namespace. So there are so many namespaces in Docker, right? As I already told you, let me open the documentation. Uh, Let me open the notepad. Docker underlying technology. If I try to open this, already told you these are the namespaces which Docker is using right now. Okay, so right now we have seen how the process ID namespace works, right? it is a it is a process isolation, which means that your process IDs which are running in one namespace cannot be seen by other namespaces which are running a process ID. Okay, so this is how the isolation is getting created, and both are sharing the same kernel namespace. Okay, so that is how it is. Now I want to show you something interesting. Is nothing but I told you whenever you run some command or when you run some particular thing from application, it will try to call some system calls and then it will execute the command. Okay, so generally if I execute ls minus l command, it is getting printed, but you don't know what is happening, what system calls it is using to use in order to talk to the kernel. If you want to see that, you have to give something like strace. Okay, strace, and then you give the command what you are trying to run. If you execute this, you can see there are so many system calls which it is running. Okay, if you scroll up a bit, okay, there are so many system calls which will get activated and which will get closed once the operation is done. Okay, you can see here, if you scroll up a bit, you can see it is executing a command called this command, and this command is there in the path called, it is present here. Okay, it is showing you the entire binary path of this absolute path. Okay, You executed only a relative path, but you don't know where this command is actually called from. So this utility is called from this location, and this is the command which you're trying to execute, and this is where it started. Okay, and then here on it has opened so many process ID, like it has called so many system calls, like you can see mprotect, okay, and set tid, set robust list. Okay, there are so many things, so many process IDs, like system calls which is used. Okay, so many things will get opened, and those will get closed actually. Okay, so if you start digging into this, actually it will show you a lot of information. You can see this is the output, right? In the sense, you can see there is a write system call. If you want to see that in the browser, let me open that system call. Yeah, I opened this or that. What happened to this? Okay, I think somewhere I opened. Yeah, here it is. So if I open this and go back, and I want to see write system call, right? So you can see this is the system call. So this system call is, you can say, write to a file descriptor. So this system call is used to show you the information over here. Okay. So you can see, you are able to see the output of that particular. See, if I execute a normal command, it is giving this information. Same thing you can see here. Once this got executed, it has been closed. Okay, so this is how it is. If you want to dig something, or something the command is getting hanged, or something kernel got, some particular system call is not working as per expectation, you can execute this strace, and you can give the command what you're trying to run, and you can dig and see what it is exactly doing. Okay, so this will help you, or in order to simplify the job, or in order to troubleshoot something. Okay, so this is how it is. Okay, so is that clear till here, whatever we have discussed? So I've shown you how the systems call will get activated when something you are trying to run some command, or when you're trying to execute something on Linux operating system through application or through CLI. It will use lot of system calls in order to interact to the kernel. That is what we have seen with strace. And then I have shown you the process ID namespace. Okay, how to create with the Docker. In the Docker, we have to create a two containers. For the two containers, it has created two different namespaces. Okay, and then everybody is using their own namespaces, like in their own namespace they're running its own namespace, like process IDs. Okay, if you want to share the same process namespace, then you can create two containers on the same namespace with the help of the command what I've shown. Okay, so this is the basics related to your um, namespaces. Okay, process ID namespaces and all. I'll give you this documentation. This documentation has some video which is provided by Red Hat, which talks about the same thing. Okay, you can just walk through that particular documentation. Okay, now let's say you are doing through Docker. If you don't have a Docker, if I want to create a namespace in Linux operating system, what is a command? Okay, does does anyone know, actually, since you people are already working in Linux operating system? Did you know like what command we use in order to create a process namespace in Linux operating system without using Docker, without using any containerization tool? Any idea? No? Yeah. So here is the commands. So now you can execute this command. Okay. So let's say this command will try to create a process ID namespace, process namespace. Let me copy it properly. And in that particular process, we are trying to use a shell. Okay. So here, when you execute this command, what will happen? It will create a new namespace, and you will log into that particular namespace actually. Okay. So let me show you. Let me open another terminal, and I will show you that actually. Let me minimize this. That is possible. What I will do, I will minimize this. Okay. Okay. Do is like I can. Okay. Now, if I execute this, let me log in from here as well. So sh root at the rate 192.168. So now ls ns hyphen t pid. Okay, so these are the only namespaces which you have. Let me clean up all the containers what I have. Stop. I'm stopping all the containers. Okay, because I don't just want to do a cleanup. Yeah, done. So let me remove that. Done. Now you have only one namespace, that is a process parent process namespace. Okay, it is a root namespace. Okay, now so let me try to do like this. Okay, now if I execute this command, oh, what happened? Yeah, done. Right, I logged into that particular namespace actually. So let me show you the proof. You can see a bin bash. Whatever command I specified on the left hand side, you can see it created with the process ID. You can see that number on the first column, and you can see the actual process ID of that particular thing. Okay, if I execute ps aux command pipe grep, okay, 21206, you can see it is running bin bash in that particular process. Okay, so this is how it is. Means I actually whatever the command I am executing right now on left hand side, it is executed on that particular namespace actually. Okay, so if I execute ls minus l or something, let's say I execute some sleep, let's say 100,000 and then yes, okay, and I'm running some 2000. Okay, so now if I execute ps command, you can see it is showing me only these things. Okay, but actually uh, where it is getting executed, it is executing in my process, this particular namespace actually. Okay, in this namespace it has executed the command right now what I executed on the left hand side. It has executed in that particular namespace. Okay, so now if I try to look for that particular process id, it will show you only this information. Okay, okay, now let me show you something. 2121206. Yeah, you can see this. So the parent process ID is 21206, and under that we executed two sleep commands, right? You can see here. This is one sleep command with 1,000 and sleep command with 2,000. Means this is 1,000 seconds, 1,000 minutes actually, and this is 2,000 minutes. Okay, so we executed this command. These two commands inside the process, like in the host machine, it is this is the parent process ID, and this is the child process ID, and this is the child process ID. Okay, now can someone tell me, if I kill this particular parent process ID, what will happen to this two child process IDs? Any guess?
Almost it also will kill.
Will go in zombie process.
Zombie process, right? Exactly. It will, yeah, zombie process. So now, what we will do, we will come out of this particular shell. Okay, now, and you can see this wiped out. Okay, means like actually that particular process ID namespace will be existing until I log in there. Okay, so once I exit, you can see here there is no some process which is running like that. Okay, now if I execute a process ps aux command on the left hand side, it is nothing but you are executing. You can see in the history I don't see ps aux command which I executed. Okay, why? Because you executed inside that particular process. Now you can see it is showing the whole bunch of information. Okay, so this is the way to identify that. Okay, at least you had some picture now, or anything that you got confused. So if you want to manually do that, so that is a command which we have to use. Okay, in Linux operating system, you can use whatever you want here actually, not only bin bash, you can use whatever you want. Okay, let's say if I execute sleep, let's say 5,000, I have 5,000 actually, like whatever it is, it is actually should be given a percentage symbol, but I have not given that. Okay, so now if I execute lspls command, you can see 5,000 process is running right now. Okay, if I stop this, okay, now you don't see that actually. Sorry, you will see that, but it is stopped. Okay, That is how it is. So yeah, so this is all about the process namespaces and their things. If you want to see the arguments and all in lsplc, you can give something like, you can see the command, let's say this is not actually needed, but okay, you want to see the process with hyphen e hyphen o, okay, PIDs, you can see the actual command, it is PIDNS, okay, and comma PID comma arguments. You can see it will print all the process IDs and the namespace and the examples. Let's say you created some container docker. Let me try to utilize that container run. Okay, now I'm using this. It is just a C1 container. Okay. Now if you execute lsns hyphen t PID, you can see the process ID. Okay, now I want to see the whole bunch of process IDs which are running in this particular namespace. Okay, if you want to do that, ps, okay, hyphen e hyphen o, okay, PIDNS comma PID, and then auth, and then you can give only this particular namespace ID. Okay, so this is how it is running. So I got the information which is related to that particular namespace. Okay, so this is how we can use it. So these are the maximum number of options which you have in order to identify the process ID namespaces. Okay, so if you want to learn something, writing a Go language and executing this, she talks about that. Okay, if you are familiar with Go language and all, if you want to do some operations related to process ID namespaces and all, she explained like Liz Rice. So she has explained about how to do it actually. Okay, you can go through that particular documentation. So here, if you want to see what I have created, like these operations which I have done here, below this video, okay, you can, if you want to see it again on the videos, you can just see this Red Hat official tutorial which talks about the same thing. Okay, which explains about the same thing actually. But ultimately you have to understand every process which is running, whether it is a terminal or whether it is a script, shell script, or anything Chrome or any application, Nginx web application which you are running, everybody who are running on the Linux operating system will try to use the system calls in order to talk to the kernel, and kernel will will pass information to the hardware. Okay, okay, so this is all about your process ID namespaces. Okay, is that clear? We'll go to the next level. I want to show the network namespace. So till now we talked about process ID namespace. Now I want to talk about network namespace. So is that clear? Any questions or any doubts? No, thank you. So let us go with the network namespace. Okay, I don't want to show practically to create a namespaces and attach a V pair and all, practically showing it in Linux operating system. I want to use the existing Docker, and I want to show you how to identify the namespace related to that particular Docker container, network namespace of that particular Docker container. If you want to practically create a Linux operating system namespaces and all, network namespace, you can watch this particular link. Okay, how to create a network namespace in Docker containers, or you can look at the below of that. Okay, they have practically shown how to create a namespaces in Linux operating system without using any containerization tool. Okay, network namespaces. Okay, how I shown this one, right? Without using Docker containers or any other containerization tool, how I created a namespace related to process ID. If you want to do any operations related to network namespace without using any containerization tool, this last thing you can use this link. Okay, so try to use that. I don't have sufficient time, so that's the reason I cannot show you practically, but one day I will give you some script. You can execute that script, it will create all the necessary things. If you want to modify something, you can just modify that particular shell script. Okay, okay, done. So when you create some particular Docker, actually it will create a network namespace, process ID namespace, mount namespace, UTS namespace, and then all the 7 namespaces whatever it is needed. Okay, I told you it will do this with the help of, okay, a container format. As I already told you, this is the flow, right? When you try to create something from the Docker CLI, it will pass the information to the Docker daemon through REST API call, and the Docker daemon will pass the information to the container D using a gRPC call. Right? So it will use some Docker shim in order to talk to the container D. Okay. So Docker shim is one of the library like which will use unnecessary actions in order to talk to the container D using a gRPC call. Okay, remote procedure call. Once a container D has received the information, it will pass the information to the runc, which is called as a open container interface. One of the open container interface which is called as a runc. Okay, so it will talk to that particular runc by downloading all the images and what other things are needed to create a container. It will create a OCI bundle, open container interface initiative. Sorry, open container initiative bundle. It will create, and that information will be passed to the runc. Once a runc has received the information, it will use all the lib containers, like it is a wrapper actually, which is called as container format. So it will use that particular container format called lib container, a wrapper, to do all the necessary actions which are needed to create that container. Like it will pass information to the namespace, what it should be done. It will talk to the C group, what it has to do, and it will talk to the UFS, Union File System, to do what is needed for Docker. Okay, so it is distributing the task to each and everyone. Everybody is not doing the same task. Everybody has their own individual job. Namespace will do only namespace related actions. C group will do control group, which is what is a C group? Control group in the sense it will try to ensure that your containers are not crossing beyond the limits related to CPU, memory, and then storage. Okay, so this information will be controlled. This will be controlled by your C group. Okay, union file system in the sense, when I told you there is a container layer and image layer. Okay, when you are writing some information in the container layer, which is a read write layer, it will use some file system. Like by default, your Docker in Linux operating system will use overlay to storage driver. Okay, so we have so many other storage drivers. I've already shown you practically how to change from one storage driver to another storage driver. If it is not done, I will be showing in the further classes. But for batches who has already done, I have already shown that actually how to change from one storage driver to another storage driver. I've shown them practically, like changing from overlay to BTRFS. Okay, storage driver. So that will be done by this particular task. C group will do the control groups. Namespace will do all the namespaces actions like creating a process ID, network namespace, and thing. Okay, so now we need to talk about network namespace. Okay, so let us do that. So this diagram is clear, I hope. So let's go to the next step. Is that clear, or you have any questions in this diagram? So in someone is asking you about related to interview questions. So if you have some understanding about this diagram, you can crack the interview. Like something, if someone is asking something related to Docker, you can like you can crack the all the questions whatever they have asked. It is that in depth actually. Okay, so this is more than enough. Yeah. So now let us see how to check a network namespace in Docker containers. So let us try to create a container first, as usual. So let me do that. Let me close this one. It is no more needed. So I think I've already created a one. Yeah, it's already created. So one container is already running in my scenario. It is already created and it's running. Now I need to get information from this particular Docker container to do the necessary actions to see the network namespace. Okay, what is that information? Is nothing but PID. Okay, so PID information I have to see. How generally we execute? So we can execute Docker container inspect, and then you give your container name, and then you execute. So here I need to scroll up and I need to search for PID. That is what we do generally, right? So if you try to do something, scroll up, scroll up, scroll up, and then you search for PID. If you're not able to see like this, then we do something like pipe grip. PID. Okay. So let me execute like this. Pipe grip. Okay. PID. You can see this 21289. So if I give this 12, 2.1.8.9. You can see this. Whatever I've given in the command of the Docker, it is running with the same thing. The command is sleep. Is it running the same sleep command? Okay. So here PID is nothing but your process ID of that particular container. So this is the process ID which is allocated by your Docker host machine to run this container. See, container is nothing but a process which is running in your Docker host machine. Simple. If someone asks you something, container is nothing but which will have only libraries and binaries of that particular application to run that application as a process on the Docker host machine. That's it. Okay. So now what I want to do is nothing but yeah, I got the process ID and all. Let us go to the next steps. So what I will do, I will execute this command in order to simplify my job and store that information of process ID output into a variable. Okay, so that is what I'm trying to do right now. So let me take this, not copied properly. Let me do it, and here instead of this I want to give my container name is C2, right? And yeah, it will store this information. If you want to see this, PID, you see this 21289 done. So this information is stored in a variable, environment variable called PID. Done. I want to reuse it actually. That's the reason. Now I want to create a directory called mkdir. You can see here I've pasted here. Okay. So -p where run it. It's already there actually. Okay. So no need to create. Okay. I think it's already created. So no need to do anything. Where run net. Okay. Net. And then what happened? Net ns. Already created. Okay, no need to create. If it is not there in your case, just try to create. I gave this example. Actually -p is not needed. You can just give, because we are not creating any tree directory, right? Okay, so just you need to remove that -p option. Yeah. Now what we are trying to do is nothing but always remember this is your process ID. Okay, so with this process ID, all the process related information will be stored under /proc directory of your Linux operating system, as you already know. Okay, process related information will be stored here. Now your container is having a process ID called 21289. So now if I give /proc 21289, 21289, you can see this whole bunch of information is related to your container. Okay, in that I want to search for net ns. You can see ns, which is called as nsl namespace. You can see C group namespace, IPC, MNT, net, PID. This is a child process ID, user and UTS. So these are the maximum namespaces which will be created for every container which you try to create with the help of Docker. Okay, if you want to see that, first of all you need to get the pre-ID of the container, and then you need to execute this command. So this will show you the things. Okay, ns-t. So now let's go. You can see here, try to understand. This is your, see, these are different IDs for each and every namespace. C group has its own number, PIC has its own number, MNT has its own number. Just I want to show whether this POS ID namespace is correct or not. Take this number and see this. Is it same? Same, right? You can see here actually, these two, which is process ID related. Both are having the same ID. You can execute this command and see it. You can check the last two numbers, last four numbers, 2257. Okay, so perfect. This validation is done. Okay, now what I have to do? Now I want to create a soft link with this particular location network. Whatever I have, this one, I want to create a soft link under this particular directory. This directory which is already there, I want to create some with some number actually. This number, it's up to you. What number you try to create? This number I want to create. Okay, and then I want to create a soft link. So just copy this, create a soft link. Actually, you can take your container ID actually. Okay, if you want, the best practice is your container is having some ID, right? Take that number actually. I will take this one now. I'll copy this. I'll paste it in my document so that you will understand why I did like this. Okay, so take this one. So it is for better understanding, saying that okay, this ID, based on ID I can identify. So I'm creating a soft link of this particular file to this. Okay, why I'm doing this? Because I need to log into the namespace actually. So that's the reason. Okay, now after doing this, you can see the information related to that actually. Okay, ls minus l slash proc dollar pid, okay, ns, and then net. You can see, oh, what happened? You can see it has successfully created a soft link. Done. Okay, now let us take the advantage of this. Okay, once you do this, you will have a network namespace which you can use it in order to log into that. I am trying to log into that particular network namespace. So in order to do that, we have a command called ipnet ns. Okay, this is the command which I try to do. You can see here. Okay, this is one of the namespace which I have. Okay, so now what I can do is nothing but what are the ID you have used, this one. Now this is the ID actually. Okay, now you can see the same container ID actually, the directory actually, if you see, it is the same whatever the name I have given here. So that's the reason you are able to see. Okay, now I'm trying to log into this particular namespace. So IP net ns. Okay, this is for troubleshooting, which will really help wherever you go. Any DevOps engineering or whatever it is, if you are interested, this will really help for network troubleshooting. Okay, nowadays network namespace is common. So now I am trying to log in. Without going into that also, I can just execute some commands like how we do in Docker, right? Either you can log into the namespace, or either you can log into the container, or without logging into the container also you can execute from CLI. We give docker exec -ti container name, and let's say I execute ls minus l command. So it will go to the container, it will execute the command, and it will show the results. Or if you want to log into the container, you can just give, instead of that, you can give bin bash. You can just log into the container. Here also it's the same thing. Okay, if you want to log into this namespace, you can give bash. You logged in actually. If I execute ip space a command, see, it is showing you only the container related network details. You can see this. This is a container related information. If you want the proof, let me come out of this. Okay, docker exec -ti e2. Let's give ip space a command. Oh, ip space a is not there. Let me try to install the package to show you the proof. Without logging in the container, I'm trying to do from CLI itself. I'm running update command, and I'm trying to install some package called iproute2 in order to execute IP commands. I'm a bit fast. Don't take me wrong, because I need to explain so many things, right? So that's it. Yeah. Now let me log into the namespace once again, and let me show you the output of this. Let me log out from namespace. I logged out from namespace actually, not from the terminal. Okay. Now we came to the root namespace, root network namespace. I logged into that particular child namespace of that particular container. And now if I execute this command once again of that container, you can see same information. What you have seen in the namespace, you are able to see in the container. So which is a proof. Okay. So this is how it is. Okay. So this is the network namespace. Until you delete that particular soft link or you delete the container, that network namespace will be there and you can utilize that. Okay. So this is how it is. Any questions in this? This is all related to network namespace. So if you want to practically implement like this, let's say, let me remove this thing, whole bunch of thing. Yeah, I want to create on the Linux operating system, let's say your Docker host machine or whatever it is. I want to create one network namespace and another network namespace. Okay, now there is a root namespace actually here, root network namespace. Let me note down this. This is a Docker host machine or Linux virtual machine or physical machine. It's up to you, or bare metal server. Linux virtual machine or bare metal server, it's up to you. Okay, now every machine will have a parent network namespace. Now this is called as root network namespace. Okay, now your machine is having some IP address, right? It will be in this. Okay, let's say 192 dot mine is this actually. Okay, in your case it will be different. 0.30, sorry, 0.30, right, slash 24. Okay, so this is how it looks. Now I'm in the same operating system. Okay, the same mission, I'm trying to create two namespaces. One is, let's say, blue, and one is green. Okay, this is your task actually. You'll get whole bunch of examples. Okay, and in the documentation also there. Now I need to create a link from here to this particular root namespace. Okay, this is called as veth pair. I already explained in Docker, like Ubuntu, Docker classes. This is called as veth pair. Okay, so there will be a veth pair which will be created, means a cable software. Okay, so it will create a link. One end will be created in this namespace, will be attached in this namespace, and another end will be created in this namespace. Okay, here you will be seeing with the name called veth. Okay, the naming convention of will be veth, and here you will see something like e0 interface name. Okay, here also it's the same thing. Now here also I want to establish a connection between from here to here actually. Okay, now let's see this. Let's try to understand. Here also it will be like in this namespace it will look like e0. Okay, and here it will look some with and with some number actually, or with name, whatever its choice is yours actually. Okay, now I will allocate some IP, whatever I have here, with the same IP or something like a different IP. Okay, 192.168, okay, dot 0.32. Okay, and here, or you can create a separate network. Okay, that's up to you. And if I use 168.4.34, okay, now I can communicate from here to here and here to here. This is what Docker is doing actually. Okay, without disturbing this, what you can do, you can create a namespace or bridge interface, and you can allocate some IP to this bridge interface. You can create this one using br bridge. Package name is brib bridge hyphen utils. Linux operating system, this is the package. Once you install this package, you can operate the, see, you want to create a bridge. Let's say this is not your IP address. You will create some other interface IP address without disturbing your base operating system network. What you can do, my suggestion is create with a different. Let's say your base operating system is having 10.10.0.10/24. Let's say this is the one, for example. Okay, now you created a bridge interface using a command called brctl add br. This is the command which we use actually. Let's say it is cbr0. Okay, now when the interface is created, it will look like this actually, and you will allocate this IP address kind of thing, and then you will allocate the same IP address because these two containers, these two namespaces are getting attached to the same parent namespace bridge actually. So then what it should do, now this bridge will be acting as a mediator between this namespace and this namespace. That's the reason you will be able to communicate with each other. Okay, so this is what you have to do as a task. You'll get so many examples in my documentation also. I've given the link. You can use this third link. They will show you practically how to do it. So Docker is doing the same way. Okay, you want the proof? Let me show you. So if you log into this brctl, let me execute that command, and then you have to, you can see command is there. So brctl show, you can see docker 0. What is this with? Can someone tell me?
Hmm.
Sorry, come again please.
Connection name, not device name.
Connection name in this sense. First of all,
In set.
Docker 0 bridge. This is Docker 0 bridge. You already know, right? Now this is another bridge because I created two bridge networks. Okay, one is user defined bridge network and one is predefined bridge network of Docker 0. Okay, if you want the proof, let me show execute Docker network ls. You can see this one is Sudhir. Okay, this is nothing but this one actually. Okay, and you can see the ID. Based on the ID, you can identify. Okay, 5B55. You can see 5B55. And this is Docker 0. You already see this. This is a default bridge. Okay, what is this then? For this one, it is not having any interfaces, but for this, it is having some interface. What does it mean? In the diagram, can you look at this diagram and can someone tell me?
In
So
CentOS, basically, NMCLI CANAP, it will connect to that interface like that.
forget about CentOS. Now tell me, what are the output you are seeing here? What is this? Why it is showing me interface like this number? What does it mean? Now, if you see, I have one container running, right? This container is whenever you created, it created some with pair. The with pair which is running in this bridge namespace is nothing but what you see here. Okay, the interface which you see in container right now, it is E0, as I already told you. Okay, you can see this is E0. Okay, so this is how it is. So this is nothing but an interface which is present in your namespace. Okay, and this is the interface which is present in Docker container namespace. Okay, so this is the connection. From here, it is connected to here actually. Okay, with using a with pair. Okay, so that is what it will show. If you try to create another container, let's say if I create another container called C1, let me try to do that. It's a C1 and I execute the same command, or let's say now if you see now, you will have brct, sorry, now you see two interfaces. Why? There are two containers running. So which means that these two containers are connected to the same bridge. Okay. If I try to create another container and I will say something like, let's say C3 hyphen hyphen network is nothing but Sudhir. Now this container is created. Now if you see the brctl show, now you can see, now you see some interface related information to this. Why? Because there is a container created. Okay. So these interfaces, whatever you see under here, this is nothing but in the bridge namespace. Okay, in the container namespace you have to log into the container and see. Okay, that will be obviously e0 at the rate some number. Okay, so this is how it is. But the point what I'm saying, any questions? No questions. Okay, so let us go to the third namespace called uts. Okay, so let me open that. um ls minus l, I just want to show all of them. Sorry. This is the one, and for c1, now if you see this, I want to see information related to 21289. Okay, so now these are the namespaces which you have. Now let us talk about UTS. What is UTS exactly? So UTS is nothing but what are the host names you create to the container will not get reflected in the base machine. Why? Because I will tell you. My host name is this on my Docker host. What is it? Test ubuntu.server.tld. That is my host name actually. Okay. But if you log into your container, you will see a different host name. Why? Because it is created on a separate namespace. Okay, so that will be done by UTS, domain and domain name and hosting. Both the changes you will see only with the help of this namespace actually. Okay, so now if I created a container, right? So if I log into the container -ti, it's a C1. Okay, and if I give host name, you can see this is my host name. Okay, because of this host name, it is not affected my base operating system, right? So those are isolated with each other. Okay, so this is related to your UTS namespace. Okay, and one more point. So this is so simple actually. No need to go in depth actually. If you want to read something, I think I documented it. If I not documented, you have to. You can just search in Google. You'll get a lot of information related to UTS actually. Okay. So this is the example. Just I want to show. Okay. So UTS namespace in the sense whatever the changes you do in the container namespace related to that particular host name change or a domain name change, that will not affect your base operating system or any other container which is running in the same Docker host. Why? Because every UTS namespace is different. Okay, so that is the intention of using this namespaces actually. Okay, now, but when you try to use a network namespace, let's say if you try to create your Docker, can I have my Docker host namespace to my container? Is that possible? Can I have my Docker host namespace, okay, to my container related to host name and all? Is that possible? How? If I create my container with the help of network called host network, it is possible. Okay, let me show you. Let me try to create a container. Let me clean up first. Stop C1, C2, C2, C3. I'm just doing cleaning up so that I can show you from scratch. See, you already know about host network, right? What is the benefit of it? It will share only the network namespace to your container, which means that the host name also will get reflected. Actually, if not, let's see. Which means that it is not getting shared. So let us see if that is getting changed or not. So Docker PS, I don't have anything in stopped as well. Okay. So Docker container run -d and then -network net host -name C1, or I will not give anything. And then I'm using Ubuntu in order to run some count sh-h -c sleep 1 day. Okay. Now if I see my container is running, okay, my container is having its own name. Now if I log into my container and if I look at this uh, C1, what is the name? Yeah, some random name. And then yeah, host name. You can see that's ubuntu.server.tlt. Okay, or if you just give host name. So I executed this hostname command on my container. So when you try to give host network, the host network will be shared as well as your UTS namespace also will be same. Okay, so which means that whatever the host name you are seeing on the container on the Docker host machine, okay, it will reflect. So this namespace will be same. Whatever the host namespace is used, same namespace is used by your container. Not only that, it will use the network namespace what your Docker host is using. The same network namespace will be used by your container. Apart from that, process and everything is different. Okay, only network and UTS namespace will be shared on the Docker host to your container when you use this option. Okay, so this is what you have to remember. Okay, when someone asks you information related to that, you have to understand this. Okay, is this point clear or any questions? I've shown thing. I already shown this actually. This is related to UTS as well as network both. It will cover both actually. Yeah. Any questions? No? Yeah. So the last topic of the day is nothing but mount namespace, right? That is the only one which is left. So mount namespace is nothing but, so you see some information related to here when I execute df-h command. Okay. So now you execute df-h command, right? So when you execute this command, you see a lot of bunch of information actually. Did you ever got some doubt saying that if I log into my container and if I execute df-h command, what will happen? Have you ever thought or have you ever seen any information? Any guess at least? Can someone tell me what is this exactly? Hello,
It is
I'm audible.
storage only. Audible. It is storage. Na?
See, storage, yeah, fine. Okay, what is this exactly? This is a overlay storage type,
Docker
file
some.
system type, which is created specific to your container. It's container related storage partition.
In Docker
Okay,
form, it's
not Docker spam, forget about that. Okay, you can see here, whatever your root directory is using this partition, the same has been shared to the container as well, which means that your container can use 51 GB. How your Docker host is using. Why? Because we have not controlled anything saying that this is your maximum limit. Okay, since I have not done that, it can use this entire 51 GB. Okay, your container is right now it is doing that. Okay, so if you want the proof, let's say my container is running right now. What is your container ID? This ID is different, but don't think that it is your container ID. If you try to do an inspect of your container, you will come to know that Docker container inspect. Okay, and then inspect, yeah, container name, and then enter. Scroll down a bit, scroll up, scroll up, scroll up. Yeah, where is it? You can see this. These are the direct data which is has been showed of your container. Okay, this is how it is. You can see the ID. Now this one and that one is equal. Let me show you that practically. Now let me take this. Okay, if I try to do df-h command. Okay, now if I give ls minus l and that, is it same? Okay, so this is how it is. So it will mount actually. That is called as mount namespace. So which means that this mount namespace and it has a different namespace actually. If you try to create another container, let's say if I try to create another container, let's say I will name it as, I will not name anything, just I will execute 2d. This is another container. Now if you try to execute df-h, now you see two overlaid file systems. Okay, why? Because we have created two containers. There are two containers running in the background. Okay, so that is how it is. So if you try to execute this command ls minus l in this particular directory, now you'll see whole bunch of directories, but it doesn't mean that where is your directory, that mount related information that you can try to do and inspect on that container. You'll get this ID related to the mount and you can see. So every directory has its own information. Now, if I log into this container, let me just give ps command. Okay, docker exec hyphen ti b df hyphen h. You can see this. It is showing you like as if you are in the same. You can see it is showing you as overlay. This is your actual thing. Okay. It is not only that, it is showing you the host related information as well. But your main partition is now it is showing you as overlay. Okay. But if you log into your container, sorry, Docker host machine, and if you try to execute this with overlay, you will see that. Okay. You will see like this. In the container, you will see like this actually. Okay. So these are separate namespaces. Okay, if you look into your second namespace container, it will look like this. This. Okay. So they are separated with the namespaces. So this is called as a empty namespace. That's the reason these are isolated. Okay. So this is a whole bunch of information related to your namespaces and all. This is really important for us if you are trying to write some CKS exam, Kubernetes Certified Kubernetes Security Specialist. Okay. So when you try to come across that, you have to have some understanding on this actually. Okay. Namespaces and all. So now we discussed about process ID namespace, network namespace, UTS, and then we discussed about mount namespaces and all. Okay. Yeah. So that is all for today. So this is what I want to discuss. I hope these points are clear. Okay. The task which I gave you, just try to complete that. Okay. You can look into this. I will send you this as a PDF documentation. You can try to utilize this. Okay. You have this videos and all. So I'll create a documentation this. I will try to make it as a PDF and I'll share in the WhatsApp group for everyone. Okay. And then I want to show one more thing. Yeah. This is what I've discussed today. Entire thing and all. C groups, union file system, container formats and all. Okay. And then this is not needed for us. So let me close this. I just want to recall everything. So if you want to understand the system calls, as I already told you, you can just search in Google, you'll get this documentation and all. Yeah. One more last topic that I want to discuss is nothing but, so you understood this diagram, right? I'll send you this diagram as well. Okay. So I just need to add one arrow mark like this. So you can run some system calls actually. Okay. This is too wide actually. Weird actually. It's not that. Which one I can use? So width. I was not able to. Can't I customize this? Okay, it will be like this. But somewhere I can insert view size cannot be reduced. That's okay. So this is, I just want to explain. I just want to show with this diagram saying that you run a system calls from application directly to you can call the system calls, or you can send it to the libraries. Okay, means like you can talk to the library. It is too weird actually. Let's not use that. No, I will use this one. So what I'm trying to say is, yeah, you can send information to the libraries and libraries will try to call the system calls. Okay, I just want to explain that, so that's the reason. Diagrams are, I can just copy paste this one. That's okay. Let me not. Yeah, let me explain. Yeah, so from applications you can call the libraries and libraries will help you to call the system calls, or your application can directly call the system calls. Both the ways, both are accepted actually. Okay, so these are the things which I will try to explain. Like this diagram also I will try to share. This is one more thing which I want to discuss. Yeah, it's automatically saved. That's fine. So this is done. This is where I stored actually. Yeah. Now the last topic, which is nothing but as per. So this is really important. If you are working on a security team, we have to ensure that our Docker is deployed and it is running properly in production servers as per CIS benchmarking. So CIS benchmarking is nothing but cyber internet security. Cyber internet security. So what they will do is nothing but they will give you some guidelines telling you that if you want to run Docker as a secured way, you have to follow these things. Okay, we can customize, but right now they will suggest you a few things and they will ask you recommend, and it will tell you what are the changes you need to done. This is the documentation. I will share this documentation as well. which will tell you like ensure a container has a separate partition, which means that as already told you, right, we need to create in production servers, we have to create a separate partition for var lib docker. If you have not done that, when you're trying to run this particular tool, which is called as docker benchmark tool, when you try to run that, it will tell you what is a violation. If you click on that, it will tell you what need to be done. Okay, so then you can read this documentation and it will tell you what are the solutions and how to fix it. Okay, so what it is telling you, you have to create a separate partition for your docker host. Okay, that is var lib docker. Okay, similarly there is another suggestion, ensure that the version of the docker is up to date. That is one more thing. Okay, so that is one more thing which you have to take care of, that you can check with docker version, see what is the latest version, and it will do automatically on audit. Okay, these are called as audit logs. Okay, so this is really important for Kubernetes also. It is there, since everybody doesn't have idea about Kubernetes because we have some new batches, so that's the reason I'm not talking about it. Okay, later on I will create some special video related to Docker security CIS benchmarking. This CIS benchmarking right now I'm showing related to Docker. Okay, so how I can do this, there is a separate documentation, this is the GitHub link. Okay, which talks about Docker benchmark for security. Okay, so to run this you need to execute this command. This command will run all the audits against your Docker host machine. Okay, so try to execute this. Once it is done, it will remove. You can see this, I gave -fn rm, which means that once a container has successfully run that command, whatever it is defined in the command, once it is run successfully, the container will get deleted once the output has been shown. So execute this, and you can see it is using host network. You can see it is running some test. Okay, you can see some are like warning, some are note, some are like info, just an information. See, some are passed, which means that you are, see, ensure abnormal policy is enabled, you have already enabled, so that's the reason it is passed. All the things you have almost, you have to fix it, or you can skip. Okay, now you can see these are passed. Actually Docker swarm related things are passed. Okay, ensure Docker swarm mode is not enabled if not needed. So if it is not needed, I have not enabled it, so done, it is passed. So you can see all the Docker, see this section related to Docker swarm, and this section is related to Docker security operations. Okay, and then it is telling you solutions. It is what it is telling you, avoid image sprawl. What does it mean? There are currently 14 images, only 3 out of 14 are in use. And you can see avoid container sprawl. There are currently totally 3 containers, which 3 of them are currently running. So which is okay, fine for us. This is just an information actually. It is not a warning to worry about. Okay, whatever you see in red color mark, that is important for us. Okay, let's say it is telling you the pos id limit is not set. Limit is not set. Here you can see I have not set any process ID limit for this. By default, I created a container, but I not set any limit to the process ID. I told you, right, we can set some limit to process ID, memory, and CPU. Like if you want to, the memory, CPU, and RAM. If you want to do that, you can do. And you can see here, I'm not running any health check related to that particular container. The 2 containers which are running. So it is telling you that. Say privilege is not restricted. So these are like some of the violations which you have. You can fix it and you can run. Okay, so this is container image and build related information. Okay, it is telling you that you have not written any health check related to that image. Okay, and then you can see some are passed here. This is Docker daemon related information configuration. Actually this is Docker daemon configuration. Okay, and this one related to host configuration, means on your Docker host machine, are doing all the things are followed or not. It is telling you that ensure the auditing of the configuration configured for the Docker file and directory under this. Okay, and there is a etc directory. Ensure the auditing is configured for Docker files and this. Means like it is asking you there is an auditing done for this particular directories. Okay, ensure that auditing is done for this particular directories. So all these directories, it is asking you to do a proper auditing on this. Okay, and you can see here, ensure Docker is up to date. You are using 20.10.5, verify it is up to date as uh, deemed necessary. If see whether it is latest or not. Let's say if I run docker, not let's say apt hyphen cache policy docker hyphen ce. Now what is the latest version is the same. If I run update command, I told you right, info and all you can ignore. Just a warning you need to take care of. Now if I see it is the latest one, so I no need to worry. So what are the output is showing me, that's okay, fine for me related to Docker. Okay, so this is really important if you want to pass benchmarking. CS as per CIS benchmarking solutions is this like your cluster setup is done. Why? Because some clients will ask you, is your cluster is CIS benchmarking passed? If it is not passed, they will ask you to fix it in production service. So that is really important for us. Okay. So if you want to take care, you can take care of it. So you can see here, ensure a separate partition for containers has been created, which means that right now I don't have a separate partition for Docker. It is my varlib Docker is running under the root. I don't have a separate partition. It is asking you to do that. Why? Because tomorrow if your Docker is crashed, or your operating system is crashed, the separate partition which is there may not get affected. Okay, so for that reason, or if your Docker is affected, the operating system is not affected. Okay, so that's the reason. So they are asking you to create a separate partition as per CIS benchmarking. It's up to you and your client or your senior, like whatever they want to use benchmarkings. If they want to avoid this benchmarking, they can skip it. Okay, when you're trying to do some CI/CD operation or something, you can just add it. Okay, so if you want to learn about this, this is also implemented. See, benchmarking. Okay, so this is related to Docker benchmarking. If you want any other thing, you can just register. It will download. It will send you an email like this. I registered. It send me a link. Once I open this, it will open so many things. In your Linux operating system also, you can run the CS benchmarking. If you want to run your Linux operating system, you can see here distributed independent Linux. If you want to run on Microsoft Windows, you can run this, and it will tell you what violations, what benchmarkings you are not following as per CIS in your Linux operating system. So you can add a suggestion to your team actually saying that let us try to utilize this benchmarking suggestions and let us try to build our cluster based on this CIS benchmarking. So that will add an advantage to you from cyber security, cyber violations. Okay, so that is all about CIS benchmarking. Okay, Center of Internet Security. So this is all information from my end. This is the whole bunch of information. If you have any doubts, please let me know at any point of time. Always you can drop me an email or like you can ping me in WhatsApp group if you have any suggestions related to or any queries related to this topics. Yeah, yeah, that's all for today. Um, is that fine or any questions?